Hello children. Lesson number 5, Operation on Rational Numbers. Under this lesson today we will see how to use the Bodomas rule or rules of simplifying the expression that we are going to see now. So yesterday we seen this before that solving of examples was remain, that we will take, and then we will move towards the rule. So first of all, here you have to divide the pi upon 3, we have to convert into the decimal form. So here 5 upon 3, so here 3 ones are 3, minus remains 2, then 0 take, here point after 0 gives, otherwise directly 0 taken or point finish, here we have to give the point. 3 6 are 18, okay, subtraction again here. Here remains how much? 2, again 0 taken, again here 3 6 are 18, again here 18 will come, here subtraction which will come? 2 will come. So when you solve this example, you will notice that the number 6 is repeating always. Again you will divide this, so you will get the answer of this question. 5 upon 3 is 1.6666. no, is never ending. Okay, so at that time when the number is repeating, at that time what we have to give? Here we have to write it in this way, 1.6, and on the head of 6 we have to give here dot. Give here dot. Okay, I will give it with different color. See here we have to give the dot. And what is the meaning of this dot? Is the 6 is repeating. Okay, so in this way we have to solve. See here it is given. In above examples, the division does not comes to the end. Division is not ending when we divide it. One example we seen here, we seen that the division is not ending because 2 it is repeating. Here the single digit of the group of digit occurs repeatedly. One single digit is repeated or group is repeated, that I will show you now, on the right hand of the decimal point. And this type of decimal form of rational number is called as a recurring decimal point. What we said to this? Recurring decimal point. In the decimal fraction, single digit occurs repeatedly on the right hand of decimal point. We have to put a point above it. See here how on the head of 3, or just now we seen that 1.6 on the head of 6, I put here dot. In that way we have to put the dot on the head of which number is repeating on that number. And then afterwards, and if group is repeated, that example not it I had taken, that time what we have to do? On the head of that group, means suppose in this one of the number inside 18, the answer is 18, 0.18, 18, 18. In this type of answer will come. Then at that situation, what we have to write? We have to write 0 point, and which numbers are group of number is repeating? 18. So just give the bar on it. Said this is called as bar. Single digit is there, we have to give the point, and more than a group of number is there, we have to give the bar on it. So here we shown it as a horizontal line above the digit. So after that's why we have to give the point, because the same number is repeating when you solve this. Now 2 we have to if we divide 2 with the 11. If we divide 2 with the 11, you know that 11 is smaller than, here we are taking the point zeros, here 11, you know that 2 is smaller than 11. So at first we have to take 0 here, 0 here, subtraction 2, and now write this 0 here, and point down. Now you have to give, because single digit was finished here. After one digit point is there. Now next 20 is there, so 11 ones are 11, remains 9. Now you take 0 here, 11 8s are 88, do the subtraction, 88. Now here you will get the 2, again take 0, 11 ones are 11, remains 8, 0 take, sorry, it remains 9, 0 take. Then again 11 8s are 88. Subtraction, the remainder is how much? It is 2. So you will notice that here the same digit is repeating, 1 8 1 8. Again if you solve forward, you will notice that you try to solve and this, see this, the same digit is repeating, digits, that is 1 8 1 8 1 8 is repeating. There is a no end, we are not getting the exact answer at last. So such a type of situation is there, so we have to write it in this way, 2 upon 11, and its decimal fraction is the, or decimal form is the 1 8. On this 1 8 we have to give the horizontal line, it is called as a bar. Okay, so solve this example in this way. Now the third question is the, see here, this one is the third question. 7 divide with the 3. Okay, you know that how to 7, here 3 2s are 6. First of all 3 1s are 3, 3 2s are 6. Subtraction is there, 10 came, 1 remain, 1 will remainder here, 0 copy down. Then 3 3s are 9, here 3 is there. Again if you divide this, you will get 1 10 3. So when you solve this, you will get continuously 1 1 1 only repeated answer. So here 1 integer 1 upon 2 integer 1 upon 3. When you solve this, here 2 is there, we only divide 1 by 3. So here this 2 you have to write here only, and the 7 we divide, no. So here 7 divided by 3 is equals to, or 2 integer 1 upon 3 divided 1 upon 3 is equal to 2.33333, and that's why 2.3, and on its head point we have to give, and at last 50 we have to divide with the 6. So here 50 divided by 6, 50 divided by 6. So first of all, here 6 50 is here, question, 1 minute. Here decimal form of 5 upon 6, 5 upon 6, here the mistake is there. Okay, 0, here we want 0 but not this place. Okay, so this is mistake in the textbook. So here how to divide this I will show you. Compare, you just hit here, I will solve and show you the first step only. So first of all 50 we have to take it here, and here we have 50 not 5 we have to divide. Question is 5 divided by 6. As you know that 5 is smaller than 6, so 6 table inside 5's number is not there. So here we have to take at first 0 0 minus, here is 5. So do the correction here. Here 48 directly they had taken. It's not the way for you. Then afterwards here point after here zeros we are giving, take 1 point, and here also give the point. And now 6 8s are 48, remains 2, 0 taken. 6 3s are 18 minus, again here remains 2, again it is remaining 18, 6 3s are 18, again it will come here 2. So when you solve this, 5 divided by 6, you will get the answer 0.333 continuously, and that's why its answer is 0.3, and on its head we have to give the dot. Okay, so in this way we have to solve this example. Okay, so all of you complete this. Here it is given how to solve this. Just now I shown you how to do this, and here now I know inside there are some rational numbers are terminating decimal form while some are recurring decimal form, and these examples, 4 examples we solve, these are called as a recurring decimal point because they are same number is repeating, there is a never ending, this division is not ends, that's why it is called recurring decimal point, a decimal form. And some examples here ends, for example this example 2 integer 1 upon 5, and such a type of example is called as a, which here it is given terminating, and this another it is recurring. Okay, now the next point is the, let's discuss Without using division, we can tell the denominator of a fraction whether the decimal form of fraction will be terminating decimal. What they told you, without using division. Now here we had done the division, but without doing that division, we have to discuss this. Can we do this or cannot? Okay, you just discuss, think about it. So here 24th exercise you have to solve. Now here let us discuss inside the arrangement. This was only VS, I told you started, we will start with this. Here are two operations are there. Example is same. 72 divided by 6 plus 2 into 2. Okay. But when Hausa solved this example, she got answer 16, and then that of the Mangru's answer is the 28. Hausa's answer is 16 and Mangru's answer is the 28. Then whose answer is correct and whose answer is wrong? That we have to decide. Okay. Now, so whenever such a type of examples will come, whose answers are correct and whose are not, that we are going to discuss. See here, there are some rules whenever we have. First we will see the rule and then we will decide whose answer is correct. If more than one operations are carried out, then the multiplication, division are carried at first. See here what they told you. If more than one operation, in this example inside, division is there, addition is there, multiplication is there. Such a type of operation, more than one operations are there. First of all, what we have to do, multiplication and the division. After that, addition, subtractions are carried out. Then addition and subtraction. Okay. And then from left to right, for both left to right, from we have to start from left to right. If there are more than one operation in the brackets, follow the above rules while following. And this is called as a Bodomas rule. Which rule it is called as? Bodomas rule. B for bracket. If bracket is there, then bracket first we have to send. O for bracket of division, multiplication, addition, subtraction. B for bracket of, if in the example bracket is there, you have to solve the bracket at first. If not, then left to right check, division is there, then division solve, then multiplication, addition, and then subtraction you have to do. So let's check who is example is correct. So he had done 6 are 72. So here it is 12. He done the addition, division at first. But here she also done the division only, because left to right it came first, that's why. Now here Hausa 12 plus here this see written here as it is 2 2s are 4 means see this rule she had followed. BODMAS means she had the division at first and then multiplication. So 2 2s are 4. So she followed the rule, and then 12 plus then addition she had done, subtraction is not done. So 16. So Hausa's method is correct. Which mistake Mangru had done, that we will see. This step is correct for him. So he will get half mark for this exam step. But where he had done mistake, now he done the addition of these. But according to rule, what we have to do here? Multiplication. So the Mangru done mistake here, and that's why here his answer is wrong. Clear? So in this way we have to solve the examples by using the rule Bodomas. Okay. Now here these 4 examples are there. That examples we will see in tomorrow's lecture. Today we will stop here only. We seen the rules and some the solved examples. So today we will stop here only. Okay. Thank you and have a good day.